DeepSeek has been dominating the news lately. First with the post-training of their Flash model, then they also released their V4 Pro 0813 model, which is currently competing with other top models like OpenAI and Anthropic. Their latest breakthrough is a paper titled A Programming Paradigm for Spatiotemporal Composability. This is like a blueprint of how AI agents should work. DeepSeek is saying that the next frontier of AI should be self-evolving AI agents. Imagine an AI that can modify itself while it runs. It can swap out tools, it can swap out memory modules, or even sub agents on the fly. Right now, software has major limitations. For example, to change a component, we usually use a brute force method, like restarting the whole program. If a self evolving AI agent tries this, what happens is that it will drop its memory, it can kill active tasks, and even crash the very system trying to fix it. Let's take VS Code for example. We already have dynamic plugin system with VS Code. VS Code can load those extensions while you code. However, to remove those same extensions, because they work with what is known to be like a shared room or a shared space, you cannot completely remove it without disabling every other extension. So what happens is that you usually have to restart the whole process. This is the problem DeepSeek is trying to solve, and they've divided this into what is known to be as a temporal problem, which deals with time and effect, and then a spatial problem, which deals with components and their relationships. So let's look at temporal composability, which is all about time and tracking actions. When a piece of code loads in an environment, what happens is that it usually changes the environment by maybe opening up files, it also claims memory, and then also triggers different kind of events. In software engineering, this is what is known to be as effects. DeepSeek idea now is what is known to be as a revertible effect. That is, every time a code runs, there must be like an undo button attached to every action that code implements on the system. And the system tracks this action using the last in first out order. Think of it like stacking a plate. The last plate you put down is the first plate you must pick up. And for this to work, effect must be strictly independent. That is, one component undo button cannot accidentally mess up with other component data or even corrupt a neighbor's data. Now let's move on to spatial composability. Spatial composability is all about spaces and relationship between different components. If effect is what happens to your environment, co-effect is what your code needs from the environment to run, maybe like a database or a configuration file. So the old way of doing things is that when you load a component or when you load a code, the code usually asks the system for database or maybe require different resources it needs. But the new way DeepSeek is saying is that the code will sit back, or that particular component sits back while the system watches the environment for a change. So if a database suddenly becomes available, the system informs that component needing the database to react. DeepSeek also tracks who provide dependencies, not just what it looks like. Imagine swapping a water provider in your house from company A to company B. The water stays the same, but the processes and then the bills involved with the water company might change a little. And because relationships are tracked, shutting down things becomes a coordinated issue. If component A provides a database to component B, you can't just kill component A when you no longer need it. What happens is that you need to inform component B for it to finish cleaning up. Only then you can act on load component A. Now let's move on to what is known to be as a unified context and Cordis. This is where the architecture now comes together. DeepSeek merges the effect and the co-effect into what is known to be as a unified context. So think of the unified context as a digital ledger for your component. If a component needs a database, it asks the context. If a component changes something, it tells the context. Everything goes through that single notebook or that single ledger known to be as a unified context. And to prove this isn't just like an academic math, what DeepSeek does is that they built a real engine called Cordis to run this paradigm. In Cordis, running a component which is called a fiber, it doesn't just mean you are swapping between an active or maybe a dead state. They also move through different smooth and intermediate states using an initial. So we know the whole unified context thing works because the paper highlights Koishi. And Koishi is an open source chatbot which has over 4,000 community plugins. And thanks to this architecture, users can install, update, or completely delete a plugin while the chatbot is actively talking to people without ever restarting the core applications. So let's move on to system boundaries and limitations, because as you know, no system is perfect. For example, what happens when a code interacts with another API or maybe another company database outside DeepSeek control? The paper makes a strict rule between what is known to be as an acquisition and then an emission. An acquisition are things that happen inside the system. For example, opening up a local file or maybe allocating a memory. The framework can easily hit an undo button to reverse this process. But for emission, this is like sending a data to an external API or maybe sending an email or maybe charging a credit card. You cannot just magically unsend the email or reverse the debit that works with the credit card. So to handle this, number one is withholding. That is, developers have to make sure that they are 100% sure everything is fine before continuing with the action. Before continuing with the action. And then we also have compensation, that is, writing a manual cleanup script. So if you accidentally create a file on an external server, there must be a compensation script to go delete that file. So let's move on to a problem which for now we don't have an answer, and then that's the dependency versioning. The paper admits that because you're working with external database or maybe an external API, they can change several things and then do not even inform or do not change the key or maybe the process required for those keys. And for this, there's still much work to be done. But in conclusion, DeepSeek proposal is profound. They are arguing that a software should not just blindly execute code. The system must know exactly what every component changed and exactly what needs to be done in order to reverse those changes in real time while the software is still running. If you stick around to the end of this, please click on the like button, click on the subscribe button, and also click on the notification bell for when I drop more videos.